Hello everybody, we're talking about functions and relations in this credit, and just to review what we talked about with the cubing and the doubling, we took a number of steps, right? So the first step we had one cube. This is the cubing relationship. So in the first step we had one cube. On the second step we had 2 times 2 times 2, or 8 cubes. And then the third step we had 3 times 3 times 3, which was 27 cubes, and so on, right? So this relationship between these two numbers is called a relation. And this relation, because it has a way of turning one number into the other, exactly one other number. There's no other number that if I have my third step, I have some other number. So turning one number into exactly one other number is called a function. So a function is a process by which one input is transformed into one output. So the function in this case is called cubing. So you take a blank and you transform it into that blank times itself 3 times, right? And the notation that you would see is this little superscript, so that number cubed. Okay, so functions are a way to turn one number into another. The doubling was also a function. So we had our steps, and we had the number of cubes. So in the first step we had 1, and there was 1 cube. Second step there was 2 cubes. Third step there was 4 cubes. Fifth step there was, or fourth step, there were 8. Right? And this one actually, it's a little bit tricky, but you take you're taking a number and you're multiplying it by 2 each time, right? Times 2 times 2 times 2. And so this would be 2 times 2 times 2. And so how many times are you multiplying 2 times itself? Well, to make it actually fit so that it's a 1, the first number is a 1, you have to take 2 to some power, because repeatedly multiplying the same number is what exponents are, right? So this is 2 cubed. But so it's me 2 to some power, right? Some blank power. But I have to subtract 1 to make it fit this chart, right? Because if I want this one, will have to be 2 to the 0. This one will be 2 to the first power, 2 to the second power, 2 to the third power, and so on. So it's a little tricky, but you get the idea that one number gives you exactly one output. Okay. There are other relations that are not functions. So let's take a look at one of those. You could have, maybe in a computer, you want to find out the distance a student lives from school. So we have Michael here that's 8 years old and he lives 10 miles away from school. We have Johnny that's 7 years old and 15 miles away from school. And we have Christy that's 6 years old and 2 miles away from school. So we have age and we have distance, right? So are these numbers related to each other? Well, they're related, but there's no real functional relationship between how old you are and how far you live from school, right? So 7 and 15, 7 and 5, 8 and 3, 8 and 8. So we have these different relationships, but I don't have a single input giving me a single output, because I could put in, like, imagine yourself sitting at the computer and you go and search by age. Would you search by age to find the distance a student lives from school? So I put in 7 and I get out 15. No. Or if I put in 7 and I don't, it wouldn't work that way, right? You'd have to have some other relationship that would give you the distance from school. So maybe address, right? Address and distance from school would make more sense. So you have an input to give you exactly one output. Or you put in the student's name, right? The student lives a certain distance from school. You have the student's name and have their distance, right? But the age would make no functional relationship. Okay, another example. Say throwing a ball in the air, right? And it follows a path, and there's a certain height at a different time, right? So this is the different times, and this is the height. So here the chart would look like, let's see, 0, 2, 1, 4, 2, 5, 6, and who knows if this is accurate. It's just made up. But notice here that 6 appeared twice, didn't it? But this still has a functional relationship, right? That the height that the ball is does matter how long it's been in the air, right? So there's a functional relationship, and the way you can say it's functional is for every input there's exactly one output. So I don't see 3 on this list again, right, to give me some other output. And I see 5 gives me 6, 4 gives me 6.5. You know, so I have, for every input there's exactly one output. Over here I had every input was giving me different outputs. On this list, say I go back and again I test and I say, well, what happens when the time is 3, right? So when the time is 3, I still get the same answer. I still get 6. So I could have the number twice, but it has to give me the exact same output, right? So that's the way functions work, is one input, one output.